Hi, this is Dr. Solomon from Round Lake Physics, and we are going to talk this today about doing some algebra review. The very first thing we want to talk about is making sure that we know what parts of the equation we do first. This is known as PEMDAS. That is the order of operations, and the way I like to remember it is, please excuse my dense Aunt Sally. An easy way of remembering it, but what it really means is that first we take a look at the parentheses, then we look at the exponents, then we multiply, then we divide, then we add and subtract. Now, oftentimes in algebra, we're doing things backwards because we want to undo it. So if we want to undo it, that means we go in reverse order because we're going to be undoing it. So today we're going to be taking a look at how we could use PEMDAS to correctly solve some algebra problems. The next piece of advice is combine like terms. So for example, if you were to have something like x plus 2 is equal to 2x, let's just say it like that, well, we can just combine these different pieces. How would we do that? Well, I'm going to get rid of x on both sides, and it'll be 2 is equal to x. Why am I able to do that? Because there's an understood 1 right there. So that understood 1, I'm going to end up subtracting both sides, and boom, I know x is equal to 2. The second thing is you want to always get an unknown out of the denominator. So if you were to have an equation that looked like this, oh boy, how do we solve that one? Well, we need to get the x out of the denominator. And recall that this line right there is a big hint. That line tells us that we'll be using division. So how do you undo division? I'm going to undo division by multiplication. So if we multiply both sides by x, x will get distributed to this side, and x will get distributed to this side. And so x times x will cancel out, and you're left with 2. And on the other side, x times 3 will end up with 3x. So we always want to get the unknown out of that denominator. Let's do an example here. Here's a physics question that you might see, and the equation is kind of interesting. We'll talk about it later in the year, but it says F is equal to capital G times capital N times lowercase m divided by r squared. So let's say that we wanted to find what r is. How would we go about doing that? Well, think about the example of PEMDAS, and the first thing we would like to do is get that guy out of the denominator. So I want to multiply the whole thing by r squared. Why not just r? Well, because we haven't dealt with that exponent yet. So we can just carry that exponent with us. It's on our back, and we'll deal with it at the end. I'll show you. So now we multiply everything, both sides by r squared. R squared on the bottom here is going to cancel out, but it will stick on the f side. So it's going to look like f r squared is going to be equal to capital G, capital M, lowercase m. Now, how do we continue to get r by itself? Well, I want to eliminate or move f to the other side. So I'm going to undo that multiplication by dividing both sides by f. I wouldn't be subtracting it because the opposite of multiplying is dividing. So on this side, f's cancel out. On this side, we get r squared is equal to capital G, capital M, lowercase m, f. Now you go, wait, f's on the bottom. That's not good. Well, remember, our goal is to find what is r by itself. And so because we're looking for r, it's okay that the f variable is on the bottom. In the real problem, we would have that as a number, and it would just be dividing by that number. So now we have r squared alone. Are we done? No, because we have the r. So how do we undo an exponent? It is by doing the opposite. So a square is undone by a square root. So we have to square root both sides. And then that square root undoes the square, and we're left with r equals the square root of capital G, capital M, lowercase m, and f. And that's how you get R by itself, using the idea of PEMDAS. One more example, and then we're going to be done. So here's an example where I want to get T by itself. This is another physics equation, the common physics equation, F equals V plus AT. And we want to get T by itself. Well, using PEMDAS, we're going to go backwards, and we're going to first get rid of this guy. Why? Because it's added, the V is being added, so let's get rid of the addition first by doing subtracting V by both sides. So we end up with F minus V is equal to AT. And now I want to get T by itself. And how is A attached to T? Through the process of multiplication. So the opposite of multiplication is dividing. And so we'd say F minus V divided by A equals T. And that's all there is to it. So we're going to do some practice now. Join me on back on Canvas so that you can do that practice. Have a great day.